Okay, in this video, I want to go over what's called the binomial theorem. Okay? Maybe? Okay, the binomial theorem uses property of combinations. Remember, around the OGT time, we covered combinations and permutations. Well, here, or it could have been yesterday's lesson, depending on what time of year it is. Here, we're going to use the idea of combinations in order to generate the row off of Pascal's triangle directly. Now, the reason why we need an alternative here is because when you get into the higher powers, and let's say you don't have any notes in front of you, in order to get to the row of Pascal's triangle, you're going to have to start drawing that out. So if we're going to the 7th power, before you even start the problem, you need to start drawing this out. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And here we're only to the 5th power, and we haven't even started the problem yet. So it'd be great if there was an alternative way to get the values without having to do all that arithmetic. Well, there is, and it's this idea of combinations. The numbers out in front of your variables can actually be generated by doing combinations. Okay? Now, this expression here for the binomial theorem can look really scary, but basically all your variables are being treated the same way they were before. A goes to that nth power, then you subtract 1, then you subtract 2. You just keep going down until it disappears. The B here, if you count backwards, starts at the power and it goes decreases by 1 all the way down until it disappears. Okay, so the variables aren't an issue. What's the issue is getting the row off of the triangle quickly. So let me show you how to do that with the combinations. So for the combinations, before we even start this problem, let's look at how we can generate this. So n is the power. So this is going to be 7 combinations of 0. That should generate the very first number off the triangle for us. The next number is going to be 7 combinations of 1. Then 7 combinations of 2, 7 combinations 3, 7 combinations 4, 7 combinations 5, 7 combinations 6, lastly 7 combinations of 7. So this, plugged in your calculator, will get you the row right off of the triangle. So let's see if we can't show you how to do that. So on your calculator, if you put 7, then go to Math, go over to Probability, and option 3 is Combinations, and we do 0, 7 combinations of 0, well, that's a 1. Well, we already knew that that was going to be a 1 because our rows always start with a 1. Okay? So we really didn't need to do that one. Second enter, switch, if you hit second and enter, you can recall the expression quickly and then just go back and edit the 0, change it into a 1, and you get a 7. Well, again, we really didn't need to work that one out because we knew the second number should be 7 because remember the second number always matches the power. Okay? So now, switch the 1 to a 2 and we get 21. Okay? So on here, this term is 21. So that's actually the first one that we really needed to work out. So now, let's do the 3. We get 35. Second enter, change the 3 to a 4, and we get another 35. Well, look at that. 35 started to repeat. Well, we know from the chart that the second half is just a repeat of the first half. So this is already repeating, which means I don't need to keep going. I only needed to calculate out 7C2, 7C3, and 7C4 on this one, and I get all the rest of this for free because the next number's got to be 21. The next number after that's got to be the 7, and the last number's got to be the 1. Okay? So we could get the whole table by just computing 3 values, 7C2, 7C3, 7C4, on our calculator, and we get all the other numbers for free without having to draw this whole big chart. Okay? So now that you have Now that you have the chart drawn out for the 7th power, now we can spread these out. So this is 1, 7, 21, 35, 35, 21, 7, and 1. Okay? And now we can just start filling in our variables. Okay? So for the x term, we're going to start at the 7. So this is going to be x to the 7. This is going to be x to the 6, x to the 5, x to the 4, x to the 3, x to the 2, x to the 1st, no x's. Then for the y's, no y's, y to the 1st, y to the 2nd, y to the 3rd, y to the 4, y to the 5, y to the 6, y to the 7. Okay. And on this one, because our sign is negative, remember out front would be a positive, in between the first two terms would be negative because you only have one negative y. Remember the y is negative, you have one of those, so it's negative. Then it's positive, negative, positive, negative, positive, negative. So there's your final expression. It's a very long answer, but there's not much work. Okay? And something else to help you, because sometimes you'll get lost in your powers, sometimes you lose your place. Notice that all your powers here always add up to your original exponent. 7, 6 and 1, 7, 5 and 2, 7, 4 and 3, 7, 3 and 4, 7, 2 and 5, 7, 1 and 6, and then obviously just 7. Okay? So that's a quick way of getting the coefficients using the idea of combinations, so you don't have to use the whole triangle, and then it's just a matter of filling out the terms. Okay? In the last video, I'll cover the last two problems.